Hi, my name is Asheley Landrum, and I'm an assistant professor of science communication in the Department of Advertising and Brand Strategy in the College of Media and Communication at Texas Tech University. Today, I'm going to talk a little bit about the roles of knowledge and identity in predicting acceptance of science or public acceptance of science. My hope is to dispel some of the rumors and myths that are the cause of some of the arguments that we see in the literature. Why, for some issues, are there such large gaps between what members of the public believe and what science knows? Here are some data from Pew Research Center comparing members of the US public to members of AAAS, recognizing that members of AAAS aren't all scientists. Many are, but others are science adjacent. People who might be science teachers in elementary or secondary school as well. So that is one little issue with this. But we can see that there are still like these large gaps between the public and those who are science adjacent. If we look, for example, at the belief in climate change, so that the Earth is getting warmer, mostly because of human activity, you see that there's a 37 percentage point difference between members of the public and those of AAAS. If we look at the belief about human evolution, so humans and other living things have evolved over time, again, we see a 33% gap. Beliefs about childhood vaccinations, such as MMR, should be required, recognizing, again, this is a policy question, not a acceptance question, but that there's an 18 percentage point difference. And the largest is this 51 percentage point gap between US adults and members of AAAS in the belief that it's safe to eat genetically modified foods. So why do publics disagree? My research has looked at three factors that contribute towards public acceptance of science: knowledge, identity, and trust. Today, I'm mostly going to be talking about the first two and how they interact with one another in order to influence public acceptance of science. But in truth, all three are necessary and are interrelated. So one of the most intuitive explanations for why people don't accept science is that they just don't know about science. If they just knew the facts, they'd change their minds, right? Well, this intuitive theory of science denial is referred to as the knowledge deficit hypothesis and is held by a variety of scientists, educators, and figures in public policy. In fact, this past summer, many of you might have heard on the news doctors or public health officials lamenting that people don't act appropriately to mitigate against the risks of COVID-19 because they just don't understand the science. So concepts that are related to this belief or are related to the knowledge deficit hypothesis and are sometimes used interchangeably are the information deficit model as well as the public deficit model. These models state generally that public uncertainty or skepticism towards certain scientific issues is the result of a lack of knowledge about those specific scientific issues. So if we want to address that, then it follows that addressing this problem should involve providing adequate education and or teaching scientists how to communicate more clearly or more effectively. So what does this look like? If we have increasing knowledge on the x-axis, that here, and increasing acceptance on the y, then we'd expect to see, again, this nice long line of as knowledge increases, so does acceptance. However, this assumes that people who are at the lower end of knowledge would be completely skeptical and not accept anything at all. It's also a part of the knowledge deficit hypothesis to say, well, maybe acceptance starts at a 50-50% likelihood of accepting or rejecting a specific issue based on the amount of knowledge that somebody has. So either one of these could show support for the knowledge deficit hypothesis. So again, this seems intuitively correct. So why do communication scholars refer to the knowledge hypothesis as being debunked? Well, what do we mean when we say that the knowledge deficit hypothesis is debunked? Perhaps most importantly, the consensus report on science literacy from the National Academies of Sciences say that studies using measures of science knowledge observe a small positive relationship between science literacy and attitudes and support for science in general. However, the relationship is small, and available research does not support the claim that increasing science literacy will lead to appreciably greater support for science in general. So bottom line, the consensus panel on science literacy finds that while there is a statistically significant relationship between knowledge and acceptance, it is small, and there's less evidence that interventions to increase science literacy broadly actually work. So I'm going to start by listing my takeaways a bit early in the presentation, both so I have the opportunity to repeat them, but also because it will help structure the talk. So first, knowledge is relevant, but it is not the whole story here. There's a difference between measuring people's existing knowledge and the interventions that we might create in order to increase people's knowledge. And of course, the interventions to increase people's knowledge may only work to increase acceptance among certain subgroups. And that will depend a lot based on the issue and their reasons for accepting or rejecting it. So let's start with knowledge is not the whole story. So I'm going to go through 3 examples, climate change, evolution, and flat Earth. So climate change, does more knowledge equal greater acceptance? And this one, I might be repeating things that you've heard or seen before. So here's some data that my group collected with Dan Kahan. Science knowledge was measured using the Ordinary Science Intelligence Scale, and I'm happy to answer questions about that during the Q&A. And then we have the probability of acceptance on the y-axis. And again, the hypothesis here, consistent with knowledge deficit, would be as science knowledge increases, so does the probability of acceptance. So what does that data actually look like? So again, researchers run regressions and they might see, oh, look, there is a positive relationship here and it is significant, right? P is less than 0.05. However, this fails to take into consideration the most important predictor of climate change beliefs, and that's political ideology. We know that these things are extremely correlated. So if we divide the sample and regraph by political ideology, this is what we see. So although Democrats may be more likely to accept that climate change is real and human caused with increasing science knowledge, Republicans look like they're doing the opposite. So Republicans with more knowledge are even less likely to accept climate change. So this is a finding that Dan Kahan has shown in some of his papers. He postulates that people with more knowledge who are ideologically predisposed to reject something like climate change often use their knowledge to be better at motivating their own perspectives. So does knowledge equal more acceptance with climate change? Well, for those who are politically conservative, more knowledge may even mean more denial. So what about human evolution? Instead of showing you the hypothesis graph here, I'm just going straight to the data. So here's data that I collected with Dina and Michael Weisberg. As evolution knowledge increases, so does the probability of acceptance. There's clearly a positive relationship between knowledge about evolution. So again, this isn't the ordinary science intelligence measure from the previous slide. This is domain-specific knowledge. And I mean, it's a very strong relationship. But again, this doesn't take into consideration the most important predictor of evolution beliefs, which is religiosity. If we divide the sample by religiosity, we see that the positive relationship exists for the least religious, as well as those who are in the middle. But for the most religious, while there might be a slight uptick in their beliefs about evolution, they really are tending to reject it, regardless of how much they actually know. So does knowledge equal greater acceptance? Well, for those who are very religious, more knowledge does not seem to influence their views. I want to highlight, I was pointing out in the previous slides that we do see these relationships between knowledge, but at the same time, ideology matters. But knowledge does help some. And this is, I think, one of the biggest misconceptions about the knowledge deficit hypothesis is that people who say it's debunked are saying that knowledge has no relationship with acceptance. And that's clearly not true. In fact, some authors will publish statistically significant findings that knowledge predicts acceptance and then lament that other scholars have it wrong. But what we're arguing when we say that the knowledge deficit hypothesis is debunked is that knowledge is not enough. So you have to take into consideration other identity variables when predicting people's views and values towards science, especially when a topic is known to be publicly controversial, like evolution and climate change. So we have to look for those interaction effects. The sort of bottom line from these two areas is that acceptance of science increases with knowledge only when people are not motivated to reach different conclusions. However, even then, people might not even be motivated to question the science in the first place. So going back to this knowledge deficit hypothesis graph, we talked about how people who are lower on knowledge might start by rejecting something that science has said, or maybe be 50-50 on whether or not they believe it. But in some cases, it might be that people are willing to accept something even when they know nothing about it, depending on how controversial that issue is. And that's kind of what I see here with some of my work with the flat earth community. Does knowledge equal greater acceptance? Well, in this case, when we're talking about flat earth, what we really want to see is lower acceptance. So does more knowledge equal lower or less likely to accept flat earth? In this study, I'm specifically looking not at the acceptance of the belief that the earth is flat, but finding the flat earth videos on YouTube as being compelling or making strong arguments. So the hypothesis here is, again, here's that ordinary science intelligence measure that I showed you with the climate change graphs. As science knowledge or science intelligence increases, people's perception of the argument strength of flat earth videos should decrease. And that is what we tend to see with our data. So there's a strong relationship here. So in this figure, the y-axis is truncated. The scale that I had people respond on for, I think it was like 4 questions about argument strength was from 0 to 100. So in general, people aren't necessarily, the broad public aren't rating these videos as being particularly strong, but we do still see a sharp decline in perceived argument strength with increasing science knowledge. But again, like with climate change and evolution, the strongest ideological predictor of flat earth beliefs is conspiracy mentality. So we should graph by that. And so when we divide that data by conspiracy mentality, and here I've both centered and scaled this argument strength scale. So it's z-scores as opposed to the whole scale. And as well as I graph people who scored in the top 25% of conspiracy mentality versus the bottom 25% of conspiracy mentality. You can see that for people who have no ideological reason to believe that the earth is flat, they flat out reject these videos. So we don't see people who are not motivated to reject the videos, rejecting them with more science knowledge. They just reject them outright to start. But knowledge does have a protective effect for those who score higher on conspiracy mentality. So this would be equivalent for like knowledge influencing Republicans on climate change, but not influencing Democrats on climate change because Democrats would be at ceiling already. So it's similar to that, which we don't see for climate change, but we see for this. So does more knowledge equal less acceptance of flat earth? Well, for people who aren't conspiracy theorists, there's no need to even question the shape of the earth, regardless of their level of science literacy. A prism is an imperfect metaphor, but I like to think of identity as a filter through which information is processed. Everyone might be looking at one piece of information, but through the lens of their own views and values, they interpret things differently. So you might end up with different interpretations of the same message. But more than that, the interaction between your identity and the amount of knowledge that you have can lead to you forming these motivated explanations for phenomena that may fall somewhere between accept and reject. So looking at human evolution as an example, prior surveys like GSS or Pew have asked people, humans evolved from earlier species of animal, true or false? When we ask it just like that, true or false, we might see that only 29% of people will say true. 29% of people will say that humans evolved from earlier species of animal. However, if we give people more options or if we ask them to explain it, we might see that they have different explanations that try to combine their knowledge about science and how evolution works and their trust in the scientific process with their religious views and their beliefs about whether or not humans could have evolved from earlier species of animal. In this case, these are naturalists. So the 29% of people who automatically say true, these are people who will say, yes, humans evolved entirely through natural processes. And then, of course, there's the creationists. So we found about in this paper with Dina and Michael Weisberg that creationists will say humans were created by God, more or less in their current form, the end. But there's two middle explanations here too. So there's the theists who will say that humans evolved through or developed through natural processes, but those natural processes were guided by God's hand. So they're still recognizing that evolution is taking place, but they say that God is controlling evolution. And then there's the deist explanation, which says humans developed through natural processes, which were set up by God, but continued on their own. This moves to accept generally the idea of evolution, but with this belief that God created it. So God started it and let evolution happen. But this is really important because on one hand, if we just think about that true or false question, it only looks like 29% of people are accepting the science. But if we let people provide their explanations for how they're integrating the science with their identity and their knowledge, we'll see that 64% accept some version of evolution, even if they think that it's guided by God. So just finished talking about how knowledge is relevant, but it's not the whole story. Another point that I want to make is that there's a difference between measuring people's existing knowledge and the interventions that are meant to increase those knowledge points. As part of that, we have to ask, so many of the studies that are the data that we looked at before, we looked at people's existing knowledge. So there wasn't an intervention trying to teach people something or trying to train them to better understand scientific data. There was no manipulation of scientific literacy. It was people's existing understanding of science. And when we measure items in this way, we might have to ask ourselves, particularly when we're talking about domain-specific knowledge, does knowledge increase acceptance or does acceptance increase knowledge? We do have an issue of a direction of causality here. So let me show you an example. So one example, the Ordinary Science Intelligence Questionnaire that I was talking about earlier, that I've used for science literacy and others have as well, has a question in it that you want people to answer that asks about whether the Earth goes around the sun or the sun goes around the Earth. So when I was surveying flat earthers, I had to ask myself, well, is it fair to ask flat earthers about this question of whether the sun goes around the Earth or the Earth goes around the sun to measure science literacy when I know it's part of their mental model to get it incorrect? So if I ask them, do scientists say that the Earth goes around the sun or the sun goes around the Earth, then they can tell me what the science says. So they know what the correct answer is. But when I ask them this question outright, they're giving me their beliefs instead. Dan Kahan has referred to this in his 2015 political psychology article as the measurement problem. And there's sort of two facets to this. First, people are more likely to answer questions correctly when you say what scientists say, as opposed to framing that question as whether or not they believe it. As with the flat Earth example, if I say, do scientists say that the Earth goes around the sun or the sun goes around the Earth? They'll tell me that scientists say that the Earth goes around the sun, but they don't believe that. So like demonstrating that they know what science knows versus what they personally believe. Second, can someone who answers consistent with their identity look like they have all the right answers, but really not know the right answer? And when we ask questions like, do you believe or that climate change is real and human caused, that these are identity consistent items. And if we see that there is a political difference in how people answer these questions, it might be that it's because getting the right answer could be just as simple as responding with just in a way that's consistent with your identity. And one example of this, in one measure of climate change knowledge that Dan Kahan was working on, they added a question about photosynthesis, and they asked about whether carbon is good or bad. And I think it was specifically like carbon is good for plants or carbon is bad for plants. And people who know, because carbon is one of the drivers of climate change, carbon is bad. So then they think that carbon is bad for plants. And so you have to add questions into the survey that will allow for you to really capture people's knowledge and not just show that people have more knowledge because answering the questions consistent with their identity makes them look like they answer them correctly. So the last point that I want to talk about is that interventions to increase knowledge may only work on certain subgroups. And I only have one example of this to show you right now. But so we just finished a study that's under review where we talk about whether this infographic that became really popular. So it was originally published in an article in Science talking about COVID-19. It got picked up and used on social media to explain or provide a how possibly explanation for how masks can work. Whereas, somebody who's infected but not showing symptoms, wearing a mask is like shooting particles out. And you're healthy, you're wearing a mask, you're less likely to get them. You're healthy and you're not wearing a mask, you're exposed to all this. Versus, somebody who's wearing a mask and it's filtering a massive number of those particles towards somebody wearing a mask, towards somebody not. And so we exposed people to this to this infographic, and it was a pre-post test. So we had interviewed them and just asked them about, and this is just an example, how much do you agree or disagree that wearing masks helps prevent transmission of COVID? And we waited a week. We contacted them, showed them this message, and then asked them a series of questions again. And we didn't see any movement among Democrats. So Democrats, kind of like what I talked about earlier with people who are not conspiracy theorists for flat Earth, they're already agreeing that this is the case. So there really isn't any movement between pre-test and post-test that masks work. But amongst Republicans, we did see an effect of having been exposed to the message. So after exposure to the message, Republicans were more likely to agree that masks work to prevent the transmission of COVID than they were before they saw the message. But you can see there's still this clear effect of identity, where even after seeing that, they're still less likely to believe that masks work than Democrats believe. So in this situation, we see that the targeted knowledge intervention actually worked amongst the subgroup who needed to hear that information. But there are other situations in which people have talked about reactance or boomerang effects, where exposing people to an intervention ends up sort of decreasing their belief that that's real. And so it may not always work, but in this case, it did. So again, my takeaways, so knowledge is relevant, but it's not the whole story. We have to think about the interactions between knowledge and identity to really understand what audiences are accepting or rejecting science, or which types of science, which domains. There's a difference between measuring people's existing knowledge and thinking about the interventions that are meant to increase knowledge. And these interventions may only work on certain subgroups. So that's another reason why it's really important to look at those subgroups to figure out whether it's working on the groups that you really want to target. We can't only address knowledge gaps. This is what we mean when we say that the knowledge deficit hypothesis has been debunked. It's not really that it's inaccurate to say that increasing knowledge increases acceptance. We do find that in many situations, but it only happens among certain audiences, only among certain conditions. So it's important to look for those interaction effects with ideology. We need to think about the multiple causes of science rejection and their interactions in order to fully be able to address this problem. Thank you so much.